I'm good. I'm good. It was good. Another one.
Yeah, another one. Another one, like DJ Khaled. Yeah, English is a one, guys. You should get that one in English, yeah, honestly. So let's work this one out, guys. 1 and 4 over 7. Plus 2 over 3 minus 1 and 5 over 6. So it's the same rules, guys. We like to follow BOMDAS for this. BOMDAS. That's the first thing. Always follow BOMDAS. The second thing now is we want to change everything to fractions, right? It's always the same thing we do for the first question, guys. So I'm going to change the first thing to fractions. It's going to end up being 11 over 7 plus 2 over 3 minus 11 over 6. Am I right? Yeah, that's exactly what it's going to be. And then this is going to end up being, guys, this is going to end up being over 21. Okay, multiply the 7 and the 3 to get 21. And then I'm going to cross multiply. 11 times 3 will give me 33. Plus 7 times 2 is 14, minus 11 over 6. And the 33 plus the 14 would give me 43 plus 4, 47 over 21, minus 11 over 6. And then I'm just going to, well, what's the LCM between 21 and 6? I think it's 42. 42 is the LCM between 21 and 6. So I'm going to end up with 42 here. 6 goes into 42 how many times? I think it's 8 times. No, it isn't 8. It's 6 is 36, 7 times, right? So it goes in there 7 times. So this would end up being minus 11 times 7. And then this 21 goes into 42 2 times. So this is 47 times 2. And we should end up with 94 minus 77 over 42. Let's just subtract that, 94. Sorry, let's just subtract that. So 94 minus 77. Let's just subtract that, 8, 14, 7. 7 minus 8, 17. So you're supposed to end up with 17 over 42, guys. Cool. And I think that's your answer. I think that's your answer, isn't it? I don't think it can break down. Can it break down anymore? Can 17 go into 42? No, it can't. So that's the answer, 17 over 42. 17 over 42. And of course, guys, write A and S beside it, guys, so that the examiner can see that your answer is the 17 over 42. So that one is pretty simple, guys, pretty easy. Anybody need any advice on this? I think we know how to do these now, right? I think we should be okay. Remember, guys, always follow BOMDAS. Add first before you subtract. And change everything to fractions, guys, and that will make life much easier for you. Boom. I'm moving on. I'm not going to spend too much time on that. Let's move on to this now. This guy says the square root of the cube root, sorry, of 27. The cube root of 27 over 9 squared. So this would be equal to the cube root of 27 is definitely 3, guys, because 3 times 3 times 3 is what gives us 27. Does that make sense? I think that makes perfect sense. And 9 squared is definitely 9 times 9. So 9 times 9 is 81. And 3 goes into 81 27 times. So the answer is definitely 1 over 27. So this is the answer, guys. Does that make sense to everybody? We did these already, guys. We're just doing it over. We're just practicing a little bit. Make sense to everybody? We're doing the latest paper, guys, January 2021.
Yes, sir.
It makes sense to do the latest paper, guys. January 2021. If we have any more time, we can definitely do the July 2020 paper that I was talking about last night for the multiple choice. But let's continue. Let's move. We don't want to waste time. We really just want to do our thing today. So this part now, guys, I want to do this part. It says here 485. Sorry, let me clear the screen. Yes, 485 multiplied by 10 to the negative 2 millimeters. And it says a construction worker used 75 sheets of cardboard stacked together to insulate a wall. Cool. It says show that the exact thickness of the insulation is 363.75 millimeters. So guys, 485 times 10 to the negative 2, guys, that's 485 times 10 to the negative 2, guys, is 1 over 10 squared. So that's the same thing as 485 multiplied by 1 over 100. So this would end up being 485 over 100, which is 4.85. So 4.85, guys, is the thickness of one of the sheets, but they said that they use 75 sheets. So 4.85 multiplied by 75. Remember, we can use a calculator in our exam. We should end up with 363.75 millimeters. Cool. So that's the answer, guys. One thing to remember, this is just a note before the exam tomorrow, guys. If you see 10 to the negative 2, it's the same thing as 1 over 10 squared, which is the same thing as 1 over 100, guys. If you see 10 to the negative 3, same thing. That's the same thing as 1 over 10 cubed, which is 1 over 1,000. Cool. So that's just a reminder, guys. Same thing with 10 squared. If 10 squared is 100, guys, 10 cubed is 1,000. Please remember that tomorrow for this first question. It might help you a bit. Cool. So remember, guys, 10 to the negative 2 is the same thing as 1 over 100. 10 to the negative 3 is the same thing as 1 over 1,000. 10 to the negative 4 is the same thing as 1 over 10,000. Cool. Please try to remember that for tomorrow. It would help a bit, just a bit. So boom, we should get that one. The answer for this one is 363.75. You're supposed to show it. We showed it as the answer. So we can move on. Cool. So since we showed it now, guys, it says here, write the thickness of the insulation correct to two significant figures. So remember, it's 363.75. Yeah, 363.75, right? So 300, oops. Yes, guys, 363.75. If we want to write this to two significant figures. So guys, I'm just reviewing significant figures. Remember, guys, significant figures, this is the first, this is the second, this is the third, this is the fourth, and this is the fifth. Cool. Every number is a significant figure. The only ones that would not be significant, guys, yeah, there's everything here is significant still. So they said two significant figures. So if we need to find the second significant figure, if we need it in two significant figures, we need to look at the 2 plus 1 place. So we need to look at the third place. And we're going to say the third place, which is a 3, is 3 greater than or equal to 5. No, it's not greater than or equal to 5. So we're going to add a 0 to the number in front of it. So the answer should end up being 360, right? That should be the answer. And guys, for significant figures, for any number that's in front of the point, you're gonna put a 0 for it as a placeholder. These are the two significant figures, 1 and 2, and the 0 is a placeholder. For the decimals, guys, you don't write the decimals with significant figures. Cool. But for anything in front of the decimal place, you'd have to write a 0 in that place. Cool. So yes, so that's the answer, 360 to two significant figures. Another thing to guys, if it says 363.75 and you write it to two significant figures, your answer could not be 36. 363 is not going to turn into 36. It's just not possible. You need to put that 0 as a placeholder. Cool. You need to put it there. So yeah, so the answer is 360. Cool. Then it says, guys, down here, let's scroll down a bit. It says correct the same answer, the 363. Sorry about that. Yes, the 363.75. They ask you to write this to one decimal place. So guys, this is the first decimal place and this is the second. And if they want to write it to one decimal place, we'll have to look at the 1 plus 1 place, which is the second place. And the second place is a 5, guys. So is 5 greater than or equal to 5? Yes. Yes, it is. So since 5 is greater than or equal to 5, it's equal to 5. 5 is definitely equal to 5. We're going to end up with, we're going to have to add 1 to the number in front of it. So the answer for this is 363.8 to 1 decimal place. Cool. This is the answer. So that one was pretty easy. So that covers 2 significant figures and 1 decimal place. Everybody remember how to do significant figures and decimal places? Everybody okay? Want to give me a thumbs up, guys? I think it's okay. Cool. I definitely think it's okay. So that's 1 decimal place. And then the last one now is in standard form, right? Standard form. So guys, the same 363.75, we need to put this in standard form. How do you put something in standard form, guys? When you do in standard form, it has to be between 1 and 10. The number has to be between 1 and 10. How do I get 363.75 to be between 1 and 10? I need to move this decimal places 2 places to the right, the left, sorry, and I'm going to end up with 3.6375. So 3.6 is definitely between 1 and 10, don't it? 3.6375 is definitely between 1 and 10. So yes, so that's right. I have to move the decimal places here, but I have to multiply that by 10 to the 2. Cool. And 10 to the 2 is 100. So clearly, if I multiply this by 100, I would end up back with the same 363.75. So that's definitely in standard form. This is definitely in standard form, guys, no doubt. So for those who don't remember how to put something in standard form, you just have to move the decimal place right between here, right where the answer would be between 1 and 10. Cool. Tori, it's good to see you. Dejane, it's good to see you as well. It's good to see you guys. Aquino, good to see you. Anissa, Anicia, Shana K, Jay, it's good to see you guys. We're just doing the last run before the exam. So guys, we did a standard form. We did a significant figure. We did a decimal places. So we should be good. Let's go back to this CXC outline to see what we did so far. So we did fractions, we did decimal places, we did significant figures, we did standard form. So let's look at some ratios and percentages. Let's look at that for a bit. Should we look at those for a bit, just in case they come tomorrow? Let me just bring up my YouTube channel just for a second. And let me look up ratios. Yeah, let's just look up ratios on my channel for a second. Let's just talk about ratios for those who might not remember. Section 2. It's the last video in section 2. Well, no, it's in section 1. Sorry about that. Section 1. Last video in section 1, ratios. So let's talk about ratios just for a bit, guys. Just in case. Cool. Okay, why is my video not showing? All right, guys, so ratios. Let's look at a basic question for ratios. Do I want to do that one? Yeah, so let's talk about ratios for a second, guys. So ratios kind of easy, guys. It's pretty easy to me still. It says in a football academy, there are 60 members, of which 24 are attackers. And it says determine the attackers to the total members. So that's how we do ratios, guys. It's always 2, 1 to the other. So it says attackers to the total number of footballers in the academy. So the first one, guys, if you were to write a ratio for attackers to total members, it would be 24 to 60. Cool. For ratios as well, guys, you kind of want to write it in its lowest form still. Yeah, you kind of want to write it in its lowest form. So you can break this down. Yeah, I think you can break this down, can't you? I think 12 goes into 24 2 times, and 12 goes into 65 times. So the ratio is 2 to 5 when you write it in its smallest form. Cool. We're gonna write this one, guys, defenders to attackers. If there are 24 attackers, then and there are 60 members, then clearly the amount of defenders would be 60 minus 24, right? So it would be 36 defenders to 24 attackers. We can divide both of them by 12 and we're going to get 3 to 2. For this one here, guys, defenders to total members, there are only 36 defenders. And to the total members is 60. So that ratio, if we divide everything by 12, is going to end up being 3 to 5. And the last ratio here, total members to attackers, it's going to be 60 to 24, which is 5 to 2. Cool. So this is just some basic ratios, guys, to show you how you do ratios. These are ratios, guys. And maybe we should do one question still. I want to do one ratios question, just in case it comes tomorrow, right? I think that's a good idea, don't it? CXC math, past papers. All right, so guys, I'm gonna do a ratio question. Another one. Yes, let me look at the worksheets. Ratios. Ratio, and variation. Cool. So yes, guys, let me zoom into one question and let's do a ratio question, right? Let's do a simple ratios question. Yeah, let's do a simple one, not anything too difficult. Just a simple ratio question. Okay. Which one? Is one I have in mind, you know? Yes, so I want to do this question over here, guys. This is exactly what I want to do. So it says here, guys, a coach party traveled to Europe on a holiday for a number of days. And the number of days they spent in France, Spain, and Italy were divided in the ratio 3 to 4 to 5, right? So this is the ratio. And the first one is for France, the next one is for Spain, and the next one is for Italy. Cool. So that's the ratio, guys. They spent the number of days that they divided for the 3 countries were in the ratio 3 to 4 to 5. And it says that they spent 9 days in France. Cool. So how many days did they, it says here, how many days was the complete holiday if they spent 9 days in France? And how many days did they spend in Italy? So this is a pretty simple question, guys. It's very, very simple, which is why I chose it. So guys, it says here they spent 9 days in France, but based on the ratio, guys, if they spend 9 days in France, then that would be 3 times 3, right? 3 times 3 would give you the 9 days. So 4 times 3 would give you the number of days they spend in Spain. So 4 times 3 is 12. And then the ratio here for Italy would be 5 times 3, which is 15. So clearly, guys, they spent 9 days in France, 12 days in Spain, and 15 days in Italy. So they ask you, what was the total? How many days was the complete holiday? It should be 9 plus 12 plus 15. And if we add all of them, we should end up with 36 days. So the complete holiday was 36 days. Cool. And then another one says, how many days did they spend in Italy? Well, Italy would be 15 days because based on the ratio, it's 15 days. Cool. So this is a ratio question, guys. This is actually, I don't know which exam. It's a G2000. So maybe this was in 2000 CXC paper. Maybe this came. I'm not sure. It says G though. I'm not really sure. But it could be possible that you get something simple like this tomorrow. You just have to remember the ratio, guys. Keep everything to the ratio. Keep everything to the ratio. Yes, it's not too bad. It's not too bad. I think it's rather simple. Anybody have any questions with this? Anybody have any questions with this ratio thing? Shanake?
So I was just about to ask you, how come you get three times the 3 times the 4 times the 5? And I know I see that in the question, but why you get 3?
Well, the reason why I get 3 is this is the ratio, right? 3 to 4 to 5.
Right.
This is the ratio. But it says here that they spent 9 days in France. So it says here the ratio is 3 to 4 to 5 in terms of the days they spent in France, Spain, and Italy. So if France is 9 days, the only thing that's going to end up giving me the 9 is 3 times 3, right?
Okay.
The ratio is 3. So I multiply it by 3. So if I have to multiply this by 3 to get the 9 days, I just have to multiply the others by 3 to get the days for those countries, because remember it's in the same ratio.
Right.
9 to 12 to 15 is the same ratio as 3 to 4 to 5. You understand?
Yes, sir.
Making sense to you?
Yeah, man, I just did want to know all the 3. I know about the rest.
Go over how you multiply the ratio. So guys, long story short, you could even divide this 9 by the 3 to get the 3. It's kind of obvious that you have to multiply everything by 3 to keep the same ratio. Because remember, it's in a ratio. The ratio is 3 to 4 to 5.
It's like a pattern then.
Similar, yeah. It's kind of like a pattern. For sure, it's kind of like a pattern. So if the ratio is 3 to 4 to 5, and that's the ratio for the days, then if it's 9 days, this ratio has to be the same as the 4. 3 times 4 would give us 12. 5 times 3 would give us 15. This ratio is definitely the same as the 3, 4, 5 ratio. Cool?
Sir.
Go ahead.
Sir, sorry, my internet is unstable. Why you say you get the 3? Is it because there's 3 numbers in the ratio?
No. That's not why. The reason why I got the 3 is because it says here that they spent 9 days in France. So if they spent 9 days in France, and I don't know what Spain is, and I don't know what Italy is, the only thing that makes sense in order to keep everything the same ratio is to multiply everything by 3, because 3 times 3 is what gives me the 9. So I just multiply everything else by 3 to keep the same ratio. Remember, guys, it has to be the same ratio, right? So I end up with 4 times 3, which is 12, 5 times 3, which is 15. So guys, 9 to 12 to 15 is the same ratio as 3, 4, 5. If I divide everything by 3, I'm going to end up with 3, 4, 5. Same ratio. Make sense? So it's the same ratio. It's definitely in the same ratio. It's the same pattern then, like Tori said. So if 3, 4, 5 is the ratio for the number of days, and you actually spent 9 days in France, then this one would definitely be 12. 3 to 12, 4 to 12, 5 to 15. It make perfect sense. Make sense, guys? All right, let me give you another example then. Let me change this same example. And suppose it said here, the number of days spent in France was 12 days. I'm just giving you as an example. And it's the same ratio, 3, 4, 5. So suppose the days were 12 for France. Guys, clearly, the only thing that would give us 12 is 3 times 4. So in order to get the other days, it would be 4 times 4, which is 16, and 5 times 4, which is 20. So I'm just trying to show you. It making sense to you now? Making more sense to you?
Yes, sir.
All right, cool. So it's a simple question, guys. It's what you call common sense. A joke. But it really is a common sense question still. And I'm going to move on from that now. So guys, we finished decimal places. We finished significant figures, standard form, ratio, operations with fractions. So let's do some percentages, guys. Let's do some percentages.
Geez, do you want you to do the decimal places? Let me see now.
Well, you came late, Maureen. So sorry about that.
Just reach out for work.
Sorry about that. Maybe we can review it later, but I just I'm going through. Maybe when we finish. But let's look at some percentages still. Let's look at some percentages if we can. Yeah, let's look at some percentages still. So let me give myself some space here.
Sir, may I ask a question, please?
Go ahead.
All right, for the ratio question that you just did, what
Yeah.
I did what I did was to add the ratios, add the 3 plus 4 plus 5,
Mm-hmm.
and then multiply by the answer by 3. Could that work in all cases, or just do it the way you show us a while ago?
It would work in all cases, but to play it safe, just do it the way I did it. Just to play it safe, you know. It would work, but it would, to me, in my opinion, you can do it both ways, but just to play it safe, you can do it my way as well, as long as you get it right, as long as it makes sense, So percentages now, guys. So Denise, what you did makes sense. So try to rationalize your answer. As long as you know you're right, that's the most important thing, But you still can do it my way, just in case you want to play it safe. But percentages, guys, suppose I want to find 70% of 5,000. 70% of 5,000 is 70 times 50, 7 5s, 3,500. Does that make sense? That's a percentage, guys. I think that's definitely a percentage. Yeah, that's how we do percentages, right? Suppose it says, what percentage of 10 is 25, right? Sometimes they give you questions like this, guys. It's kind of easy to do this, guys. 10 over 25 times 100 would give you the percentage. Sometimes you need to find the percentage out of 2 items. So this would end up being 10 over 25 times 10 is 1,000 divided by 25. I think this would end up being how much? 25 goes into that how much times? 4. I think it's 40%. 40%. So these are some basic percentages, guys. Really basic percentages. Yeah, really basic percentage questions. I don't really see much percentage questions on the exam.
Sir, a bigger number.
A bigger number? Honestly, the reason why I'm not doing a bigger number is because I don't think it's gonna come any bigger in the exam. I'm not really seeing much percentage questions in the exam still.
Sir, like on the paper one also, sir, so they have some number like 45,000 and them something like, sir.
Well, not really still. As I said, it says percentages. So I don't know if they're gonna give you 45,000 for a percentage, I'm trying to think of any questions. Let me go, let me search for a percentage question actually. Percentage. Backside, I'm not even seeing the percentages in these. It's not really that common to come, guys. It's not that common. I'm not really seeing a percentage question. Let me try to find one though, just in case any percentages come. But these are the basics of it though, guys. Like when they ask you for percentages, they're usually just asking you to find how much it is as a percentage. Cool. You want to use a bigger number? Let's use a bigger number. Yeah, let's use a bigger number if you want to. But it's just really, this is just really well simple, guys. How do you find a percentage? Let's just go through that. Everybody knows how to find a percentage, right? Do you know what a percentage is? Percentages. Yeah, what's a percentage, right? 15% of 200. These are some easy percentages we can go through still. And they're really not gonna be any harder. They aren't. It shouldn't be any harder. So 15% of 200, guys. 15 over 100 times 200. So yeah, it's kind of really simple. Let's just do them though. Yeah, let me not do it the way he's saying to do it. I rather do it the way I want to do it. So 15% of 200, guys. 15 over 100 multiplied by 200. So 15% of 200, guys, is definitely 30. Very easy. Very, very easy. I think this is so easy, guys. Like so easy. And it's usually that easy when it comes to percentages. 25% of 300, same thing. 25 over 100 times 300. 100 goes into 300 3 times, that would be 75. You know, these are the basics they're talking about when it relates to percentages, guys. Like, it's just that easy. 40% of 500, so easy. These are easy stuff, guys. Very easy. I don't think we need to overthink these stuff. Let's move on. It's just too easy to sit and talk about. So percentages, guys, you're just supposed to know. Like, you're supposed to know what is a percentage and how to find a percentage of something, guys. It's not that hard. So we covered all of these. Cool. Decimal places, standard form, significant figures. We covered all of these. If you have any issues and you might need some help tonight, try to look through my videos. I have videos on these, or just Google it as well. Because they're not really too hard to understand. Let's move on to the more difficult stuff here. Symbolical representation, algebra and symbols with worded expressions, substitution. We want to go through this. This is usually number 2 on the exam. So I want to go through questions like these now. Let's go right into one. So boom, let's go down. I'm not doing that foreign exchange question right now. I don't see any foreign exchange on the topics. Yeah, no foreign exchange, so I'm gonna do it. So this one now, guys, factorize the following expression completely. So it says 12n squared minus 4mn. Let's factorize this, guys. We can definitely take out a 4 out of both of these, and we can take out a n. So it's going to be 4n multiplied by 3n minus m. And that's the answer. This is the answer, 1 mark. Cool. 1 mark for sure. Definitely 1 mark. Cool. Definitely 1 mark.
Sorry, I get the 3 because 4 times 3 is 12.
Yes, yes. So 4n, see it here, 4n times 3n would give me 12n squared, which is that. And 4n times minus m would give me minus 4m. Make sense? So that's why that's the answer. 4n times minus m would give me minus 4mn. So that's why it's right. I know it's right. It's definitely right. It's definitely right. Cool. Making sense to you guys? Makes sense, makes sense. Now let's scroll down to the next one. Sorry to move on so quickly, guys. Yes, sorry to move on so quickly. But let's scroll down to the next one now, guys. So this next one is kind of difficult. We did it already, but I'm still gonna do it for you again. This one is not so hard, guys. Why is it not so hard? As I said, guys, all you have to do is treat it like a fraction. If you have 3/4 minus 1/5, what do I usually do for this? I usually say 4 times 5, which is 20, over 3, cross multiply 3 times 5 minus 1 times 4, right? That's how we treat a fraction. So this over here, guys, we're not gonna treat it any different. We're gonna treat it like a fraction. And it says here, show that the left-hand side, LHS, well, it never said left-hand side, but it's trying to say the left-hand side, this over here, show that that over here is equal to that over there. So I'm gonna show it. I'm gonna treat it like a fraction, x over 1 minus x minus 4x, cool. And I'm gonna put this minus 4x over 1, and I'm gonna treat it just like how I treat this. I'm going to cross multiply. I'm going to say 1 minus x times 1 as the denominator, 1 minus x times 1. And the numerator, I'm gonna cross multiply x times 1 minus 4x times 1 minus x, cool. So that's exactly what I did. I treat it just like how I treat that fraction. I never treat it any different. I multiply the denominators, then I crossed multiply. Cool. This now, let me just rub this out for a second. This now is going to give me x minus 4x times 1 will give me minus 4x. And then minus 4x times x is going to give me negative 4x squared all over 1 minus x. Then once again, minus 4x times minus the x minus 4x is going to give me negative 3x. This is a plus, sorry about that. Minus 4x times x, negative x should give me a plus. So this is minus 3x plus 4x squared all over 1 minus x. Cool. And then I need it to look like this, guys. So I'm almost there now. All I need to do, guys, is write 4x squared minus 3x all over 1 minus x. Then I just need to factor x out of the top. I'm going to end up with x times 4x minus 3 over 1 minus x. So this shows that this is the answer. I would write answer here. And this shows that x over 1 minus x minus 4x is equal to my answer, x 4x minus 3 over 1 minus x. Cool. It's easy, guys. It's not so bad. You just needed to, as I say, multiply the denominators and cross multiply, and then shape it into this one on the right over here. Cool. To sound even super smart, like I want to come first in the island, I would just say left hand side is equal to right hand side. If I wanted to come first in the island and kind of show them say I'm right, that's what I would do. Cool. So we did this before. Every time we did this, guys, I say, oh, it's difficult, it's difficult. But I think because we've done it so many times, then we should be okay. How did I get minus 3x? X minus 4x j should give me negative 3x. I think that makes perfect sense. If I have x, that's what I end up with. X minus 4x plus 4x squared. X minus 4x would give me negative 3x. That's how I end up with this negative 3x here. Make sense, Jay? Make sense?
Sir,
All right, go ahead.
sir, that question I come in a different form.
It always comes in the same form, guys. This question always comes in the same form, where you have two like this, and you have to like shape it into this. Sometimes they have it like this, guys. Sometimes they put it in this form alone, like down here where it says this is equal to 0 and solve. So sometimes it's like that. But it always comes in this same form, this same way. I actually might do some others just to show you guys. So let's do this one now, guys. Let's do this one over here. It says solve the equation if this is equal to 0, right? So it's kind of easy to solve this, guys. We can use what we got up here on the right, x times 4x minus 3 over 1 minus x. So we can say x times 4x minus 3 over 1 minus x is equal to 0. We can cross multiply. This here can be multiplied by the 0, and we're going to end up with x times 4x minus 3 is equal to 0. This x is equal to 0, or 4x minus 3 is equal to 0. 4x minus 3 would give you 4x is equal to 3, so x is equal to 3 over 4. So the answer for this one, when it says solve the equation, it means x is equal to 0 and x is equal to 3 over 4. Cool. So that's the answer. So these questions usually come in the same form, to be honest, guys. They usually come in the same type of form still. They really do. As a matter of fact, I think I'm going to. All right, so Jay asked me some questions today. Yeah, so Jay asked me some questions today. And I'm actually gonna bring up those two questions that Jay asked me. Just for the case of it, maybe I should stop sharing for just a brief second. Sorry, guys. Okay. What the heck is going on? Okay, so sorry, guys. I just bringing up the two questions that Jay asked me. Just for a second, I want to bring up those two questions because they were good questions. Let me download them. Download. Okay, cool. So let me share my screen back again. Sorry about that, guys. I just don't want you guys. Yeah, I just don't want you guys reading my WhatsApp messages, right? I have some privacy, right? But let's go back to the pictures. I want to go to two more questions. So Jay asked me this today, this question. It's very similar. It's the same type of style question. So you're supposed to solve and factorize this. 2x squared minus 9x is equal to 0. So it's kind of simple, guys. It's very simple too. All we can do is factorize here, guys. So we can factor x out of these, and we're going to end up with 2x minus 9 is equal to 0. So x is equal to 0, or 2x minus 9 is equal to 0. So 2x would be equal to 9, and x would be equal to 9 over 2, which is the same thing as 4.5, right? So x is equal to 0, or x is equal to 4.5. Cool? Make sense, guys? Jay, is it making more sense to you now as I do it in front of you?
See that this one makes way more sense than the last one does.
Yes, it makes more sense than the last one, but it's pretty much the same way though. It really is. It's pretty much the same way. Let me give you a good example. Suppose you had 2x squared minus 9x over 3x. Well, no. Over x minus 1 then. Similar to the last question. Then this x minus 1, you just multiply it by the 0, and you still would have end up with 2x squared minus 9x is equal to 0. Cool? And then you have to factor it and then find the answers. So long story short, guys, when you get this style question, similar to this one that we just did, the denominator, guys, the denominator, anytime you have anything in the denominator, this 1 minus x in the denominator, if this is set equal to 0, the denominator, you're gonna throw it away and then use the top to solve the equation. That's why you end up with x times 4x minus 3 is equal to 0. And then you guys set x equal to 0, or 4x minus 3 is equal to 0. And then x going to end up being 3 over 4. Cool? So that's why I said this question is similar to this. It's kind of similar. The only difference is that there's no 1 minus x underneath, right? But even if there was a 1 minus x underneath, you'd just multiply it by 0 to solve anyway. You have to get rid of that denominator to solve. Cool? Make sense, guys? Anybody want to ask a question maybe?
All right, so you have the 0 here, right? Because the end result is supposed to be 0, right? And because I was doing it the same way that you just told us to do, which is treat it like a regular fraction.
Yep.
I put it over 1, right?
Yep, put this over 1 and treat it like a fraction. Multiply the denominators and cross multiply. That's what will
Right.
give you this. Yeah.
Right? But it's relation into the second one, right?
The second part says to put it equal to 0.
I know. So
And then solve. So when you put it equal to 0, put it equal to 0, we have to dash with the denominator. That's the only way we can solve. So that's what I've been trying to set you.
yeah, so do you multiply in order to balance it? So
You do multiply. You multiply in
What?
when you dash with the denominator, you know,
it's
you actually multiply both sides by 1 minus x. That's really what you do. So you end up with 1 minus x times that, this cancels that, and this ends up being 0. That's why we end up with x times 4x minus 3 equals 0. So long story short, guys, if you want to solve something like this, you have to dash with the denominator still. I just tried to say that. Get used to dashing with the denominator. If it says solve, dash with the denominator. Just dash it away. If it's equal to 0, set equal to 0, dash with the denominator and the x. If you have x times 4x minus 3, the x should be equal to 0. And the 4x minus 3 should be equal to 0. And you should end up with two equations, x is equal to 0, or 4x minus 3 is equal to 0. Cool? And then you solve, and you get the two values for x. There's always two values for x, guys. Cool?
Oh.
All right, so
I
one more thing before we move on from this. I'm going to do another question that Jay sent. Let me rotate this. Let me rotate it. So guys, this is just a basic common sense factorization type question, right? And it's set equal to 0. So for this one, guys, we need to solve it because it's equal to 0, right? But we know how to solve these, still kind of easy. We'll just open two brackets. The only thing that's going to give us 2x squared is 2x times x. So clearly in the brackets, it's 2x and x. We need two numbers that when we multiply would give me -3. And we also need 2 times one of the numbers. So 2 times A plus the B should be equal to 5, +5. Cool. So I can think of something. It's kind of really obvious that +1 times, no, not +1, sorry, -1 times +3 gives me -3, and 2 times one of the numbers, in this case is B though, 2 times 3 plus -1 is going to give me +5. So those are the two numbers I need, guys, -1 and +3. So I'm going to end up with 2x minus 1 and x plus 3 is equal to 0. In this case, it says it's equal to 0. Them don't just factorize them, say it's equal to 0. So since it's equal to 0, guys, that means 2x minus 1 is equal to 0, or x plus 3 is equal to 0. So it's two situations. Make sense? Make sense, guys? Two situations, and then you're gonna end up with 2x is equal to 1, x is equal to 1/2, or x is equal to -3. So this is another example which is similar to this number 2 type question. Anybody have any questions?
Yeah, how do you get rid of the the negative? Oh, I get it. The -3 is also where you got the 5 from.
Sorry?
I'm saying that I was asking what does the -3 come in, but then it's two numbers that when multiplied will
Yes,
give you.
two numbers that when multiplied should give you the third number,
Mhm.
right? And then 2 times one of the numbers plus the other number should give you the second number. That's how I always solve these.
Sir.
Go ahead.
The beginning of it where you have the 2x minus 1. Explain that, because me I look on it and me as the 2x square. Kind of
Well, if you multiply it out still, 2x minus 1 times x plus 3, let's multiply it out. 2x times x will give me 2x squared. 2x times 3 will give me plus 6x. Minus 1 times x will give me minus x. Minus 1 times 3 will give me minus 3. I'm going to end up with the same thing, 2x squared plus 5x minus 3. So I know that this is right.
As me look on it, if me go work it out, me I write the 2x squared, 2x.
Well, no, the only way you can get 2x squared with two brackets is to have 2x times x. That's why I have a 2x here and an x here. So that's what they're asking us to do, guys, to factorize it and put it in two brackets. We did that. 2x minus 1 times x plus 3. But it's equal to 0. So when it's set equal to 0 like that, guys, we'll have to use this and set it equal to 0. And we'll have to use that and set it equal to 0. And we get two values for x. X is 1/2 and x is minus 3. Cool. Anybody have any issues? I think I can go through a couple of these before the night done still. But I need to move on now still. Let's move on to more complex stuff or more important stuff. Let's look at this one, guys. This one says make V the subject of the formula. So this is a subject of the formula question. This can come tomorrow as well. So we'll have P is equal to the square root of 5 plus VT, right? We need to make V the subject of the formula. How do we do that? We need to make it as V is equal to everything else, right? So the first thing we need to do, guys, we'll have to get rid of the square root. So in order to get rid of the square root, we'll have to square both sides. Cool. So we're going to end up with P squared is equal to 5 plus VT. P squared minus 5 is equal to VT. Then we divide both sides by T. And the answer is V is equal to P squared minus 5 over T. Cool. Make sense? You guys see how to make the subject of the formula here?
Yeah, sir.
It's write it off, sir.
Yeah, man, take your time, man.
Yeah, I was kind of like these because it's almost like a puzzle.
Yeah, not too bad at all. This one wasn't too bad.
Sir,
Yeah, go ahead.
sir, me can tell you one and you do it, and you do it, my question, sir. Is that I want to look more complex than that one, sir.
All right. Oh, you want to give me one to do? All right, give me another one to do. That's what you're asking, Adrian. You want to give me one to do, or you want me to do another one?
So we will give you one for this, sir, make it see it, sir.
All right, go ahead. Go ahead. Go ahead quickly, please. Quick, Adrian. Quick, quick. We don't have a lot of time, you know.
Sir, it might look different than the one where you take with this, sir, but I see him something, don't it? Sir,
Not really. Go ahead, though. Go ahead.
Given that S equal half bracket U plus V bracket T, express U in terms of VS and T.
All right. So it's U plus VT.
U plus V bracket T.
V bracket T. So T is on the outside of the bracket.
Yes, sir.
Like this.
Yes, sir. And it's a express U in terms of.
So we need to make
VS.
U the subject. So we need to make U the subject here. So we need to say U is equal to everything else. So this kind of easy too, guys. Yeah, this kind of easy. First thing we want to do, guys, we need to get rid of this 2 in the denominator. It's half. So this is the same thing as S U plus V T over 2, because the 2 is the half is there. So the first thing I want to do is I'm going to multiply both sides by 2 so I can get rid of that 2 down there. Yeah, I want to get rid of that 2. So that 2 will cancel this 2. And I will end up with 2S is equal to U plus V times T. I want to get rid of this T as well, so I'm going to divide both sides by T. That will cancel this T out, and I'm going to end up with U plus V is equal to 2S over T. And then the last thing to do now is just say V, well, sorry, is U we need to find. The last thing to do now is just say U is equal to 2S over T minus V, and that's the answer. So it's the same way, very similar, not too different at all. You just need to make sure you make U the subject of the formula for this one. Make sense, guys?
Yeah, pretty straightforward.
All right, straightforward. I think we can move on. Making the subject of the formula, we should know how to do that one, guys. So which one this now? This is like speed and distance and all that. I can't bother with that. I don't see that on the paper at all. So I'm not doing that.
No,
because
I don't even.
Sir, some simple interest.
Simple interest not showing on the thing to come, bro. Remember, we're following this, you know. So substitution, symbolic representation, we pretty much do that already. Algebra symbols and worded expressions, we pretty much do that already. Substitution, I kind of want to do a substitution question. Formulas and equations. I'm not really getting what I mean by that, but I guess it's the same thing. But I want to do a substitution question still. And let me just do an algebraic substitution question for you guys, just to show you. I'm going through everything that essay come in. So let's do this one, guys. Let's zoom in. By the way, these are all CXC questions, guys. So you're still doing CXC questions here. Let's do this one. 92. This is 1992 paper, CXC. It says, given that X is equal to 2, Y is equal to -5, and Z is equal to 3, find the value of, first one says, X minus 2Y. So that one kind of easy. X minus 2Y, we just need to substitute. X is 2, minus 2 times Y is -5. So this should end up giving us 2. Minus 5 times 2 would give us 10, 2 plus 10. So the answer for this one is 12. Make sense? This is a substitution question, guys. Is it making sense to everybody?
Yes, sir.
Substitution, guys. Substitution. Next one says x times z squared. Z is 3 and x is 2. So this should be 2 times 3 squared. So this would end up being 2 times 9, which is 18. So the answer for this one is 18 for B. And the last one here says 7x over 2z, 7x plus 2z over y. So 7 times 2 plus 2 times 3 over y, which is minus 5. This is going to end up being 14 plus 6 over minus 5, which is 20 over minus 5. 20 divided by a negative 5 should give us negative 4. So that's the answer for this one. Make sense? So this is what you call substitution, guys, where they give you the values and you're supposed to just put the numbers in there to solve it. Cool. It's a very
Similar to
easy
function.
thing. Very easy thing to
Kinda similar.
understand. So you notice, guys, are going through everything them say come in. Repeat A. All right, let me repeat A for you, J. So remember they say x is equal to 2 and y is equal to minus 5. So for A, let me just rub it out and do it right here. It should be 2 minus 2 times minus 5 because x is equal to 2 and y is equal to minus 5. So this should end up being 2 minus 2 times minus 5 will give me plus 10. And the answer is 12. Cool. Make sense, Jay? Substitution, guys. Very easy to do. Very easy type question. Anybody have any questions? Speak now or forever hold your peace. Speak now, guys. Talk to me.
Sir, do B, please.
The B.
Yeah.
Let me do B then. So x times z squared. Anytime you see x and z together like that, that means times. So it's 2 times z is 3 times 3 squared. 3 squared is the same thing as 9. 3 times 3 is 9. So 2 times 9, and that's 18. Cool.
Okay.
Make sense?
Yes, sir.
All right. So guys, we're moving on. We're moving on from this. And let's go back to the topics. Let's say symbolic representation, we'll get it. Substitution, we'll get it. Algebraic
wait.
symbols and worded expressions, we'll get it.
Sir?
Formulas, I guess we get it. Equations, we get it, man. We get it.
Sir,
Go ahead.
Sir,
Go ahead.
do you think before the night's over you'd be able to go through functions?
Well, yeah,
it-
functions is on it, so we're gonna go through it, man. Well, is it? Composite functions, Yeah, so we're gonna go through it, man. We're going through everything. They say come in. That's all we're doing now. We're going through what they say come in. So this class might even go beyond 8, to be honest, guys, because we have to go through everything them say come in. You see me? We need to go through everything them say come in. So anything else? It says equations here, formulas. I don't know. I don't really think anything else would have come in section 2 still. Well, let's do this question too. Let's do this question too. Yes, it says here, the distance needed to stop a car D varies directly as the square of the speed S. So remember, guys, when I was talking about in direct variation, guys, the y is equal to kx. This question is like that. So this one here says, the distance needed to stop a car D, which is the first one, the y, varies directly as the square of the speed S. So this is equal to ks squared, because this one says the square of the speed at which it is traveling. A car traveling at speed of 70 kilometers requires a distance of 40 meters to make a stop. So they're trying to say that if S is equal to 70, then the distance is equal to 40. Cool. And it says what distance is required to stop a car traveling at 80 kilometers per hour, meaning S is equal to 80. What would D be equal to? So guys, I already told you guys about this type of question. The first thing we always need to do in this question is to find the constant, find K. How do we find k? We'll have to use the values they give us. So it says here that 40 is equal to the constant times 70 squared. And we're going to end up with, man, how much is 70 squared? Somebody work this out for me. Jaden, how much is 70 times 70? Work that out for me, please. That's a big constant still.
No, it is fairly large.
How much is 70 times 70? I think it's 4,900 actually. Yeah, so you're gonna end up with 40 is equal to k times 4,900. And this is going to be equal to 4,900k is equal to 40. So the constant is equal to 40 divided by 4,900. This 0 would cancel that 0. So it's 4 over 490. Man, that's huge. I mean, small. It's very small. But if we find the constant now, guys, we can use the same formula. D is equal to ks squared. We can use the same formula to find the distance when s is equal to 80. So d is equal to the constant 4 over 490 times s is 80 squared. So 80 squared is 6,400 still, is a big number. So you're going to end up with, d is equal to 4 over 490 times 6,400. And let me just put that in my calculator. Sorry. 4 divided by 90 times 6,400. So that's the distance, guys, 284.44. But is it? Let me just double check. 4 divided by 490. Yeah, 4 divided by 490 times 6,400. Yeah, that look right. 52.24. So that's the answer for the distance, guys. 52.24. Cool. So guys, anybody have any questions here? I think somebody may have a question. Somebody can just ask. Talia, how are you? How was the English today? Wasn't too bad? It was all right?
Yeah, it was okay.
All right, cool. Cool. So good luck, guys. I hope you guys got a 1 in English A. English A is an easy one to get, guys. Shana K, how was the English as well?
So, same as Stella said, it was okay.
All right, cool. So I'm gonna get through with that one. Still, I hope you guys get a 1. But for this one, guys, it's not too bad. Let me just explain this question one more time. So guys, this question is what you call a direct variation question. Direct variation. And the formula for direct variation, guys, is always y is equal to the constant times x. Y is always what they say first. You notice they said d here first. That's why we end up with d. And a constant k is always the same. And what they mentioned second is s, right? But here they said the square. That's why we have x squared. Cool. Make sense? Make sense,
Yeah,
guys?
so, yeah, s is x.
Yes. So s is the x in this case, and this is squared, so that's why it's squared, right? I think I've done these type of questions with you guys still. But I also want to say, guys, if it says varies, suppose it says varies indirectly, guys.
Wouldn't that be the
or
constant?
inversely.
The constant, the
Yeah, if it says inversely, guys.
Over there.
Suppose it said it d varies indirectly or inversely. It would be d is equal to k over s squared. Cool. That's what it would be if it said here indirectly or inversely. So the formula for inverse variation, guys, the general formula is k over x. Y is equal to k over x. So yeah, just remember that just in case they say indirectly in the exam. Cool. So guys, I think that cover everything with number 2 still. We need to move on, right? We can't spend here all day. Yeah, we can't stay here all day, guys. We need to move on. So, whew, I'm tired. All right, so this one now says symbolic representation. We finish all of this, guys. We're good with this now. We're supposed to, all right. So this one now, solving triangles, transformation geometry, and circle theorem, circle geometry and circle theorem. So guys, when I lie still, I mean, you guys know how to solve triangles, right? I mean, Janos there. Transformation geometry. What should I do for those? So let's look back at what it says here. Solving triangles, geometry and trigonometry, solving triangles, transformation geometry, and circle theorem. So honestly, guys, may I go through circle theorem real quick? I'm gonna go through circle geometry really quickly because I like circle theorem, to be honest. I do. I just gotta go through the rules one more time with you guys really quickly. So we're gonna go through the rules night before the exam, guys. I've sent this video to you guys so many times. Yes, sir, I don't want to be a doctor. Okay, so let's go through the rules for circle theorem. I'm not gonna go through all of these, guys. You should know what those are already. I've been through this with you guys so many times. Let's just go through the rules. So rule number 1, guys, angles at the center is twice the angle at the circumference. So Tori, if here is 100 degrees, how much is here?
Half it.
Half it, don't it? Yes, that's right, Adrian. Tori, how much is it? I think you should be with me. Thalia, if here is 96 degrees, how much is here?
Come in, so I can work it out.
Sorry, repeat that, Thalia.
So it's 48 degrees.
48. All right, nice. And Tori, if you're with me, here should be 50 degrees. Makes sense? So angles at the center is twice the angle at the circumference. Cool. This is rule number 1 for circle theorem, guys. Remember it. Angles at the center is twice the angle at the circumference. Cool. So I think we're good. I think we're good with this rule. Let's move on. That's rule number 1. Angles at the center is twice the angle at the circumference. Cool. Jaden, you remember that? Angles at the center is twice the angle at the circumference.
I think it would be best to not just go through the rules if we were like going in depth, but to show an example exactly what you mean, like on a question.
All right, let's do that. I think that's a good idea, Jaden. That's a good idea, actually, Jaden. So let's go to the same question paper and go down to the circle theorem section. You know, just to do some examples. I want to go through all the rules though, but Jaden is right. It don't make no sense to just go through the rules alone. Let's see where we can apply it, right? So let's do a circle theorem question here. Okay, cool. Cool. So, Okay, so I'm actually going to apply that same rule right away. Yeah. Okay, let's apply number 1. Well, boy, I kind of want to use a different one still. All right, let me look for a different one really quickly. Sorry about that. Guys. I just want to use that example, and as Jaden said, I kind of agree with him still. So let's look at some practice related to circle theorem. I want to look at a question though. Question. So this is the first rule, guys. Angles at the center is twice the angle at the circumference, but I want to find a rule, a question still. Let me just find a question with it. Circle theorem, circle theorem. Circle theorem. Down. Okay, circle theorem. PDF. Okay. All right. So see it here, guys. Let's zoom into one of these. Okay, so let's zoom in. Whoa, whoa, it's too big, too big. All right. So let's look at this one over here, guys. Let's just apply the rules right away. So guys, if here is 220 degrees, right? 220. How much would here be, Adrian? How much would here be, Adrian? Adrian, you with me? Tori, you with me? Maureen, how much would there
Yes.
be?
Yes, sir.
110, 110,
110.
sir.
Cool, cool. 110. So we definitely applied it and we can move on, guys. So I definitely want some examples. I want some examples for the stuff we're doing. Instead of just talking about it, let's just do some examples while we're doing it. So we should remember that one, guys. Angles at a center is twice the angle at the circumference. Please remember that rule. We should know it. We should know it. Let's move on to number 2 now. Angles in a semicircle contain a 90-degree angle. Cool. So let me just repeat that. I'm gonna repeat it 3 times so you guys remember. Angles in a semicircle, meaning the line is drawn through the center, will create a 90-degree angle. So that's 90 degrees. Up there is 90 degrees. Up here is 90 degrees. All of these are 90 degrees. Cool. So let me apply that one right away, right? Right away into a question. So guys, how much is the angle up here? Let me ask Trey, how much is that angle up here? Trey, you with me? Not sure if Trey is with me. But the angle up there is clearly 90 degrees, guys. Can you see it, Shanake? You can see it, right? Make sense? Make sense, Shanake? I think it makes
Yes,
sense.
sir. Yes, sir.
Let me go to an exam paper. Let's go to the same exam paper we're doing. Guys, this is a diameter, don't it? So up here is 90 degrees, don't it? Am I right, guys?
Yes, sir.
All right, makes sense. See, so we're applying it. So we're not just doing the rule and not applying it to a question. See another diameter there, guys? So here is 90 degrees, right? This 3P and this R is 90 degrees, no?
Yes, sir.
Make sense? Make sense, guys? So I'm just trying to show you we're using the rules. We're using them. You know, we're using them. We're not just being stupid. We're using them. We're using them. Wasn't 90 to 60 on the equation? I'm confused by that question, Jay. Sorry, can you ask that again, please? I'm not understanding. I'm not understanding the question, Jay. So that follows those 2 rules, guys, and we can clearly see that the second rule came in the exam because we have 2 places we can apply it in this question here. So we need to know that rule, guys. We need to know that rule. Once you have a diameter and you have 2 lines drawn to the top of the circle, it's going to form a 90-degree angle. Same over here. That's a diameter, 2 lines drawn to the top, it's a 90
So,
degree.
sir, that would have been the answer for the question below it. State the reason why.
Yes, yes. As a matter of fact, it would have been the question. State the reason why the angle ABC is 90 degrees, meaning up here. That's the reason why. Rule number 2. So you'd get marks for that. 1 mark. But you'd get a mark for it still. You'd get a mark. Cool. Yeah. So wasn't it 90-60 on the example you showed? I'm not understanding which example. Yo, speak, Jay. Speak. Speak with the mic if you can. I'm not understanding you.
Sir, on the example, the rule number 2, example that you showed us?
All right, which one? This one? This one over here?
Yeah.
Yeah, what you said about it?
I was asking if it wasn't 90 minus 60 to get the angle for, I think that's all.
To get which angle? This one here?
Angle O.
Angle O, this one over here. Oh, yeah. That would be 90 minus 60. Because here, let's say here is 60, X is 60. So if here is 60 and here is 90, then that angle there is actually 180 minus 90 minus 60. So we're gonna end up with 30 degrees. Make sense? For this question. Yeah, so here would be 30 degrees. And it makes sense, guys. Remember that angles in a triangle add up to 180. So if here is 90 degrees and here is 60 degrees, then here will be 30 for sure. Make sense now, Jay? Cool. And that's the type of question they tend to give you with this, guys, with this 90-degree rule. So you notice here ends up being 2p and 3p. The reason why, guys, is because the 2p and the 3p, if you add them, 2p plus 3p is going to be equal to 90 degrees. So you want to kind of remember that angles in a triangle add up to 180 when you get this type of rule, this rule number 2. Cool? So let's move on. I can't spend too much time on this because this is only 12 marks a exam anyway. Don't make no sense to spend too much time. So rule number 3, guys, angles at the same arc are equal. So if you have an arc, guys, like this, let me just draw my arc over here. This purple arc. Oh boy, that purple arc don't look good at all. This purple arc right here. If I have that arc from A to C, that means here and here are equal. If I have an arc here from D to B, this means here and here are equal. Make sense, guys? Make sense, everybody? Make sense?
Yes, sir.
All right. You want to apply it right away? Let's apply it right away. Let's apply it right away. Arc. That's the arc. Here and here. Make sense? Make sense to anybody? This 2p is equal to this q. Make sense?
And the arrow is there, so.
And the arrow is there too. Yeah. So those are equal. This is the rule, guys. This is rule number 3. Let me say it to you 3 times. Angles from the same arc at the circumference are equal. Angles from the same arc. You see the arc here? Angles from the same arc at the circumference. If you draw two, if I drew one like this, guys, this would be the same as Q and 2P. Make sense to you guys? Everybody understanding number 3? Let me just say it one more time. Angles from the same arc at the circumference are equal. Go ahead.
Sir, so basically any angle we touch the arc where it just makes sure all of them are the same.
If you draw 2 lines from here to here to anywhere on the circle, from those 2 points, they're going to be equal. That's what this rule means. That's what the rule is trying to say, guys. And that's what the rule means. Make sense? I think it should make perfect sense. So that's rule number 3 now.
Let's question.
Go ahead.
Sorry, my thing was kind of laggy, but you said that 2p plus 3p
is 90 degrees. Yeah, 2p and 3p here is 90 degrees because angles in a triangle add up to 90, add up to 180. So yeah, up here is 90. So 3p and this 2p must be equal to 90. 3p plus 2p plus 90 is 180. So you're gonna end up with 5p is 90 degrees. Yes. So as I said, for rule number 2, guys, when you have this thing with the diameter, to be quite frank and honest with you guys, I always remember this rule first, the 90-degree one. I always see that one first when I'm doing these questions. So anytime you see a line straight through the diameter, look out for the 90 degrees. Cool.
Wait, so
And look out to solve a triangle after that.
all right, so sir, the angle made at B where the line. Oh yeah, yeah. Okay.
Yeah. So cool. Let's move on. I have to move on to number 4 now. Number 4 says opposite angles in a cyclic quadrilateral add up to 180. So, okay. So there's no cyclic quadrilateral here though. Well, let me scroll down and try to see if I can see one here. So guys, this is a good example of a cyclic quadrilateral. See one here. And it says here that X is 80 degrees. So if X is 80 degrees, guys, then this angle up here must be 100. Cool. Definitely. 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 Cool.
So do you think you could send me this PDF?
Yeah. Well, I think I sent it in the group already, but yeah, man, I'll send it. I don't mind. It's kind of too much to do tonight, though. It's kind of too much to do tonight.
I know. It's just...
So yes, if here is 80, angles in a cyclic quadrilateral, let me just read the rule. Angles in a cyclic quadrilateral add up to 180. So if you draw a quadrilateral that touches the 4 edges of the circle, guys, then here, here and here must add up to 180, and here with the double bar and here must add up to 180. Cool. So this is the rule. I can't spend too much time on this now, guys. I need to move on. So let me go to rule number 5 now. This is a strange rule. It doesn't come very often. Up here, guys, this shaded region here is equal to here. And where is it? Where is it? Yeah. Yeah, and then here, guys,
angle at B.
here, which is this angle over here, this part that I'm drawing as pink is equal to this angle over here at B. Cool. So let me make it blue though. Let me just change it up a bit. So that pink and this pink is equal. And this blue and the outer angle here are equal. This rule doesn't come that often though. It doesn't come very often, but it's still good to know. Cool. Go ahead. They call this the alternate angle, alternate segment theorem. Go ahead.
Here, is it the same cyclic quadrilateral or something there?
This? No, not at all. No. The cyclic quadrilateral thing is different. See? Well, firstly, a quadrilateral has 4 sides, Adrian. Am I right? Any quadrilateral, that's why I call it quad. Quad means 4. It has 4 sides. So yeah, anytime you draw a 4-sided triangle inside the circle, these angles, this one, D and B must add up to 180 and C and A must add up to 180. That's totally different from this rule. This rule is about triangles actually. When you have a triangle inside here, guys, inside the circle and a tangent, down here, this small section is equal to this part up here, and this in here is equal to this out here. That's what you call the alternate segment theorem. It's a weird one. As I say, you don't really see that one too often. You don't see it too often. Cool. So guys, we're gonna move on from this one. And then last 2 rules, guys. If you have a radius and you draw the radius to the tangent, it always meets it at 90 degrees. That's rule number 6. So the tangent and a radius meet at a 90-degree angle. That's rule number 6.
Yeah.
And then rule number 7 now, guys. Rule number 7 is
Sir.
So yes, rule number 7, guys, is that these two tangents, anywhere you draw the two tangents to the circle, guys, the length is gonna be equal. Please remember this rule, guys, because sometimes they ask you that they always ask you a isosceles triangle question with this one. So please remember this rule. Cool. Please remember this rule. Why? This angle up here is always equal to this angle up here. So sometimes they tend to ask you. So if here is 60 degrees, guys, here is also 60 degrees, and then here is also 60 degrees. Cool. Well, no, let me do that better. So if here is 50 degrees, sorry, 50 degrees would be better. Here is going to be 50 degrees. Why? Because it's an isosceles triangle. Over here is equal to over here. And then 50 plus 50 would mean that up here is 100 degrees. Cool. That's a good example of the type of question they tend to give with rule number 7. So two tangents to a circle from the same point are equal in length. Cool. So this is a good example here. Over here is equal to over here. All right. And I'm done with this, guys. I can't go no more. I can't go no more with this one. You have to figure it out on your own. Time is killing us. See? Well, yeah, we're gonna have to go over 8 still. Okay, so solving triangles, guys. When I like, yo, you have to go learn to solve triangles, man. What would we think of when it says solving triangles, though? I would think of trigonometry, to be honest. Still, let me just say triangles, trig. All right, let's look at a little trig just in case you get some triangles to solve. Should we do this? No, I don't think we have the time, to be honest. Solving triangles.
Sir, I think it's sine and cosine.
Yeah, I think they're talking about sine and cosine, to be honest. Let's scroll down some more. Let's see if it's in this question. Solving triangles. So guys, all right, before I even move on, so related to solving triangles, let's just talk about it a bit. Does everybody remember the rules for sine, cosine, and tangent? Sine, SOH, so, ka, to, right? So sine is equal to opposite over hypotenuse. Cosine is equal to cosine, the angle, is equal to adjacent over hypotenuse. Tan theta is equal to opposite over adjacent. Does everybody remember these rules? So it's so, ka, and to, guys.
Sir,
Go ahead.
to remember it easily, you look at the SOHCA, right? And you notice you have O and H, that mean opposite over hypotenuse. The ka of the A and the H is adjacent over hypotenuse, and the tan, you have O and A, so opposite over adjacent. That's what me.
Yes, that's how you remember it. That's exactly how you remember it, guys.
You look,
but the most important thing to know, the most important thing we might need to know is how to use it, right? How do we use it? How do we use it? Suppose they give us a triangle like this one. Let's do this one. Suppose they give us a triangle like this one, right? And they say find B to D, which is over here. How do find over here, guys? It's so easy. Over here is the opposite side, guys, because it's pointing to the angle. So over here is the opposite side. We'll have the hypotenuse. So the best thing to use to find BD is sine. Sine 40 degrees is equal to opposite, which we don't know. That's what they're asking us to find, BD over 5. So multiply both sides by 5. The opposite side, which is BD, is equal to 5 times sine 40. Somebody want to find the 5 sine 40 for me? Jaden, you want to find it for me?
Their sine 40 is 0.6427.
You multiply it by 5. Multiply it by 5 for me.
3.213.
So the answer here for the opposite side is 3.213 meters. Cool. So found BD. And then the next one now it says find DC, which is down here, which is the adjacent side, right? The adjacent side is the side that forms the angle with the hypotenuse. So that's the adjacent side. So how do we find the adjacent side, guys? I would use cosine. So cos 40 is going to be equal to adjacent over hypotenuse, which is 5 again. And I'm going to multiply both sides by 5. And I'm going to get the adjacent side is equal to 5 cos 40. Somebody want to work this out for me? Trey, you want to find that for me? 5 cos 40. 5 times cos 40.
Would that be equal to 3.83?
I think it's 3.83. 3.83 meters. So down here is 3.83. And up here is 3.213. Cool. So this is how you use the formulas, guys. If you get a hypotenuse, then you're going to have to use sine or cosine. Make sense? I think that makes perfect sense. So they give us the angle here, and they ask us to find the opposite side and the adjacent side. So we'll have to use sine and cosine. This is a sine or cosine type question. Cool. That's how you use the formulas. Another thing about these formulas, guys, remember that these formulas are on the formula sheet. They're on the formula sheet. See them here? See them here? See, on the formula sheet, they even show you which side is the opposite side, the adjacent side, and the hypotenuse. Cool. So you can, even if you don't remember the formula, you can at least say, all right, let me try it out, you know, in the exam, because the formula sheet is right there. So let's go back to the question though I was doing. Let's go back to the same question I was doing. And cool, so we'll finish with that question now. We found the adjacent side and we found the opposite side. All right, so we're done with that now. Well, let's do another type of question, guys. Let's do an angle of elevation type question. I think that's what I want to do. So guys, this one now, it says here, a vertical pole stands on the horizontal ground. And it says from the top of the pole H, from the top of the pole H meters high, so here is H meters high, the angle of depression of a spot from the foot of the pole is 25 degrees. So if I draw this, down here is 25 degrees. So this is the angle of elevation and depression type question now. And it says here, the angle of depression from a spot of 10 meters from the foot of the pole. So down here is 10 meters. Let's call this, yes. Let's call this A and let's call this B. At the foot of the pole, this is a pole, guys. Down here is 10 meters. And it says sketch a diagram to represent the information showing the pole, the ground, and the measures. So this is H over here. H is the length of this side over here. Down here is 25 degrees. And down here. And it says calculate the value of H. Guys, anytime you see angle of depression or elevation, that means it's a tan question. So tan 25 degrees is equal to opposite over adjacent. Remember, the adjacent side is down here, the point that forms the angle with the hypotenuse, right? So down there is 10, and we don't know the opposite side, which is the H. Opposite side is always pointing to the angle, so we need to find H. So we're going to end up with tan 25 is equal to H over 10. Multiply both sides by 10. And H, which is the height of the pole, H is going to be equal to 10 tan 25. So Tori, you want to calculate that for me? 10 times 25?
So 4.66.
Right, 4.66. I think that's right. Cool. So I think that's right, guys. Cool. So I think we're good. I think we're good with this now. So that's solving triangles. That covers solving triangles. Yeah, that covers solving triangles. And circle theorem. So I finished with both of those. Transformation geometry though. Honestly, guys, you just have to go figure that one out still straight up. Sorry to say it that way, but transformation geometry can kind of cover a lot of things. So transformation can be an enlargement. It can be a reflection. It can be a rotation. It can be a lot of those stuff. And I really don't have the time. So for this one, guys, the answer for this one is congruent. These both are congruent. So let's look at one that's like a transformation type question, guys. I ask you for an enlargement in this question. So if you do an enlargement, you can work out an enlargement with this one. I just don't have the time, to be quite honest, guys, to go through that part. It's just too many things. It could be a lot of things, and I don't have the time to waste on that one where it says transformation geometry. I just don't have the time. Whatever I taught you before, just gonna have to manage. So let's go through these.
Function.
Yeah, I gotta go through these now. Cool. But I think I need a break though, guys. I've been talking forever. I feel like I gotta have a heart attack. Give me a break, guys. Give me like 5 to 10 minutes and then I come back. Cool.
All right, no problem.
Yeah, I gotta take a stretch. Cool. All right, guys. So let's finish strong, right? So lines, guys, lines. I definitely want to look at lines. Everybody can give me a thumbs up if you're with me. We're back in it. Let me put a little smiley. We're back in it, guys. We're back in it. So yes, cool. So lines, we need to talk about lines. And main thing for lines we need to know, this is what we need to know. Not y, sorry about that. M, which is the gradient for a line, is equal to y2 minus y1 over x2 minus x1. We need to know that. Cool. We also need to know about equations of lines, which is y is equal to mx, where m is the gradient, plus c, where c is the y-intercept. We need to know this. 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 Cool.
But sir,
Go ahead.
sir, more while, sir, they see the y2 and y1 and x1 x2 and x1, sir. More while, the point, the number them, sir, we don't know which part to put them. Like,
Well, I'll show you, and that's what I'm going to show you right now. Suppose they give you A as 1, 3, and they give you B as 7 minus 4. Suppose they do that. These are the 2 points, right? Suppose I say 2 points, A and B are 1, 3, 7 minus 4. X1, Y1 would be the first point, X2, Y2 would be the second point. Cool. Let's find the gradient for that. M is equal to Y2 minus 4 minus Y1 minus 3 minus 4 minus 3 divided by X2, which is 7 minus 1. This is going to end up being negative 7 over 6. And that's my gradient. My gradient is negative 7 over 6. Cool. Suppose they ask me to find the equation of this line. It would be y is equal to negative 7 over 6x plus c. How do we find the c value? We can put this point in there. So we can say where x is 1, negative 7 over 6 times 1, y is 3. So 3 is equal to negative 7 over 6 times 1 plus c. So c is going to be equal to, I'm going to put this negative 7 over 6 to the left side. I'm going to end up with 3 plus 7 over 6, which is going to be c as 4 and 1 over 6. So the answer for my equation of the line for this same line, guys, is y is equal to negative 7 over 6x plus 4 and 1 over 6. So I'm just trying to show you that this is a good example of how they can give you the question. They can give you the 2 points like that and ask you to find the gradient, which is m, and ask you to find the equation of the line y is equal to mx plus c for those 2 points. Cool.
All right. So can you not rub it off? I want to rub it right off.
No, I'm not rubbing it off.
so, sir,
Go ahead.
So always y2 come before y1.
Yep. Always, bro. It's always the same formula you see right there. y2 minus y1 over x2 minus x1. y2 minus y1 over x1, x2 minus x1. And you need to know this tomorrow, guys. You need to know it.
Well, remind me, what's the formula for length of a line? X2 plus x1 minus y2 plus y1 over the square root. Okay.
Length of a line. Sorry, let me give you that as well, just in case it come. Length of a line formula. Yes, the length of a line. Okay, so the length of a line formula, guys, which is the length of the line. Length. Suppose I ask you for the length of the line. The formula for this, guys, the length is equal to, let's call the length D. Well, let's call it L though. L is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. I haven't really seen this very often on exams recently, so that's why I just don't really cover it that much sometimes. But it can come, it's not impossible. But they don't ask you for it very often, but I put it just in case, you know? Yeah, so they don't ask you very often. I never see it in the last paper either. Let's go back to the last paper for a bit, guys. This is the most recent paper, right? No, I just never see it. I never see it on it. So I'm not seeing it on many recent papers. I see it on the older papers like the one I did, but I'm not really seeing it too often. But it's still a question just in case it come. But cool. But the main thing to remember, guys, is these two: the equation of the line and the equation of the line and the gradient. Cool. And how to find the equation of the line and how to find the gradient for two lines.
Listen, wait, where did you get the 3 and the 1 value?
3 and the 1. The 3 and the 1 is the value for A. I can use any point on the line to find the C.
Oh.
So I use A. So that explains that, guys. That's kind of really easy to explain, but let me just go through some other things related to this, please. I'm gonna go through them really quickly. So yeah, so guys, there are times as well when they ask you for the perpendicular line. So that's another one that it may ask you for. So we found M a while ago. The gradient for what we just found is 1, 3. B is what again? What was B again? I don't know. 7 minus 4. Right, so the gradient was -7/6, right? And the equation of the line was y is equal to -7/6x plus 4 and 1/6, right? But suppose they ask us for the perpendicular line for this, guys. How do we find that? Well, guys, we need to know this formula as well, please. I'm gonna put it right here. M2, which is the gradient for the perpendicular line, is 1 over -M1, which is the gradient for the one we found first. So how do I find the perpendicular line gradient? The gradient is equal to the negative reciprocal, which is, I'm gonna flip 7/6 and put 6/7. And it's negative, so -6/7 is gonna give me a positive. So this here, guys, would be my gradient for the perpendicular line. And the equation for the perpendicular line, guys, would be y is equal to 6/7x, right? Plus c. And what would my point be? What would my point be on this line? That's a good question still. I'd have to find the midpoint. That's another one too, guys, that I need to, let me just put that down as well. So guys, the last thing that they may ask you to find, that's something else they may ask you to find. Big M is the midpoint, but they usually call it big M. And the midpoint is easy to find, guys. It's just x1 plus x2 over 2 and y2 plus y1 over 2. So I need the midpoint, guys, to find the C value for the perpendicular line. So I'm going to find it. So the midpoint, guys, would be 1, x1, y1, x2, y2. The midpoint would be 1 plus 7 over 2, which is the same thing as 4. That would end up being 8. And the other one is 3 plus minus 4. 3 plus minus 4, which is just 3 minus 4. 3 minus 4 over 2. So that's going to end up being negative a half. So that's the midpoint. So I can actually use this midpoint, guys. I call this big M. I can use this midpoint to find the C from a perpendicular line. And so when x is equal to 4, y is equal to negative a half. So let me give myself some space here. So y, well, y is negative a half. Negative a half. I hope I'm not losing you guys. I hope you're still here with me. Negative a half is equal to 6 over 7 times 4 plus c. And then c is going to end up being negative a half minus 6, 4 is 24, right? 24 over 7. Yeah, and that's equal to c. So man, for this question, I made it really hard though. C is like a big number. What's this? 14, negative 7. So C here, guys, is actually what? Negative. Man, C is some strange value though. Let me work it out still. Let me just work it out. 24 divided by 7. 24 divided by 7. 3.42 plus a half plus 0.5. Okay, so 3.928. So I'm gonna use that. So C is equal to 3.928, guys. C is equal to 3.928. So this is the equation of the perpendicular line, guys. The equation of the perpendicular line is, this is the equation of the line. And the equation of the perpendicular line is y is equal to 6 over 7x plus 3.928. So guys, the main thing to get out of this, guys, is that if you find the equation of the line, to find the perpendicular line, you need to find the negative reciprocal of the gradient here. That's why this ends up being 6 over 7x. Then you need to find the c using the midpoint. Cool? Does that make sense to you, Jaden? Make sense to you, Trey?
That makes sense.
Yeah. So that's how you do it. And so I think that covers everything. But let me just rub out the top though. I'm gonna rub out the top for a second, guys, and just kind of write the formulas that you may need to know. Like most importantly need to know. So let me just write what you need to know, right? Let me just write what you need to know. You need to know the gradient formula. That's number 1. You need to know how to find the equation of the line, which is number 2. You need to know how to find the midpoint. M is equal to x1 plus x2 over 2. That's the first point. Y is y2 plus y1 over 2. You need to know how to find the midpoint. Big M, that's what they call it. Midpoint. You need to know how to find these 3. And the last thing you may need to find is the gradient for the perpendicular line, which is the negative reciprocal of the first gradient that you found. This is M1. And you use this to find the equation of the perpendicular line, which is M2x plus c. How do you find the plus c? Use the midpoint. Cool. So guys, if they give you a question like this tomorrow, you should be able to find the gradient. You should be able to find the equation of the line. You should be able to find the midpoint. Those are the easiest 3 things to find. Cool. And let me just talk about this type of question as well. I want to talk about it one more time. Suppose they give us a question, guys, where they just only give you the line alone. Anybody with me? You guys must be a little tired now. So guys, everybody's here with me? Look at my downloads. Yeah, so guys, suppose they give you me 2019, this was the most recent one. I think it was on the last paper we did, right? Suppose they just give you a line. Suppose they just give you a line, like one big line. Let's look at it. I'm trying to find an example like it, guys. No, I'm not seeing it. All right, suppose I just give you a line, guys. I'm trying to remember where it would be though. Sorry, guys. You guys getting kicked out. So yes, guys, I'm trying to look for a type of question like this where they just give you a line. A straight up line. Yeah, suppose they give you a line like this. This is a good question for this type of question, guys, for the lines. Yes, you're here, good. So guys, suppose they just give you a line like this and they say here, use the graph above to find the gradient of the line. All I give you is this, you know, that's all I give you. But you're supposed to be able to find the gradient same way. Y, same thing, y2 minus y1 over x2 minus x1, right? Why you can find the gradient, guys? You can use the points here. This point is 5 on the x-axis and 0 on the y-axis. And this point right here, 3, 4, this point is 0 on the x-axis and 4 on the y-axis. So you can use those points. You can use those points as x1, y1, x2, y2. So you don't need, they don't have to give you a is equal to this and that for you to find the gradient. You can always find the gradient with any 2 points on the line. Does that make sense, guys? So let's find this gradient. It's 0 minus 4 over 5 minus 0, and that's gonna be negative 4 over 5. So that's the gradient, guys, for this line, negative 4 over 5. We did this already, by the way. We did this just the other day. But I just doing it as a recap to show you guys that you can do it, right? Everybody with me? Shanake, you with me? Deshaun, you with me? So I can find the gradient there. The next one says find the equation of the line. Go ahead, go ahead.
Sorry, I'm not seeing nothing on my screen.
You're not seeing anything at all on your screen?
Yes, sir.
You can log out and log back in.
Okay, sir.
Deshaun, Shanake, are you guys having issues? Anybody having issues? Anybody having issues?
No.
All right, cool. So let's move on, guys. It asks us to find the gradient of the line. So y is equal to mx plus c. That's what they're asking you for. No, the next thing they ask you is the equation of the line, guys. Find the equation of the line. So it's the same thing we're finding in this question, guys. Very similar. So found the gradient. So the equation of the line is y is equal to negative 4 over 5 x plus c. But c, guys, is the y-intercept. And the y-intercept, guys, is the point where it cut the y-axis. The line cuts the y-axis at 4. So c is actually equal to 4. So the equation of the line is y is equal to negative 4 over 5x plus 4. Cool? Make sense? Making sense to everybody? I hope it's making sense. So that's the equation of the line, y is equal to negative 4 over 5x plus 4. The last one says the equation of the perpendicular line that passes through P. Cool? Yes, so that's what the last one says. Still not seeing it, Adrian?
Sorry, I never seen nothing where you do a while ago. So can do it back over, please.
All right. It's kind of simple, bro. First thing we do is find the gradient. So the gradient is m negative 4 over 5. So the next thing they ask us to find, guys, is y is equal to mx plus c, which is the equation of the line. So guys, the m is the gradient, negative 4 over 5, and The C is always the y-intercept, the point where it cut the y-axis. So it cuts the y-axis at 4, so the C is definitely equal to 4. So the equation of the line is y is equal to -4/5x plus 4. And the last thing they ask, guys, is the equation of the perpendicular line that passes through P. So they're really asking you for the line here. Cool. That's what they're asking you for, a perpendicular line right there. So it would be y is equal to the negative reciprocal. Remember, that's it, guys. M2 is equal to -1/m1. So I have to flip the previous gradient. I have to flip this, which would end up giving me 5/4. And -5/4 would give me +5/4x plus c. So, but guys, the fun part about it, the good part about it is that they say it's at the point P. So P is 5, 0. So we don't have to find the midpoint for this one. We just need to put the 5 and the 0 for the x and the y value to find the c. Cool. And so when x is equal to 5, so 5/4 times 5 plus c, and y is equal to 0. So that's going to end up being 25/4, right? 25/4 plus c is equal to 0. So c is going to be equal to 25/4, which is 6.25. Cool, 6 and 1/4. So that's the equation of the perpendicular line, guys. The equation of the perpendicular line is y is equal to 5/4x plus 6.25. So that's the answer. So let me make this one blue. Yeah, let me make this blue. So for this, guys, that's it. That's the perpendicular one. And this one is the equation of the line. So guys, I don't do this. I'm not doing no more. Sorry to clear it like that, but yeah, I don't do this now. I'm gonna move on to functions now. So this covers it all, guys, related to lines. I think we're okay now. Cool. So we're done with lines. We're done with lines. We're done with lines, guys. We're done with lines. And let's move on to functions, composite functions. Composite functions. Graphs of functions. So let's do that. Let's do that. Let's do that. Let's do a question like that. I think we already did one though. Let me scroll up. So this is a functions question, guys. So this is the function here. 3 minus 2x. And it says here, determine the value of a. This one is really easy, guys. So this is the function, guys. F of x is equal to 3 minus 2x. So when x is -1, 3 times -2 times -1, this should be 5. So a here is equal to 5. 0 is 3. Yeah, so that's really easy, guys. It asks us to find a, and we found a. You just need to put the -1 into the function. So f of -1 is equal to 5. Cool. We just need to put that in the equation to get the answer. So that was really easy. Genuinely, guys, functions is really easy. It's not really that hard. There are 3 things we need to know for functions, guys. Really 3 things we need to know for functions. The first thing we need to know is when you just put the value in there. So like this, f of -1 is equal to 3 minus 2 times negative 1. This ends up being 3 plus 2. 2 negatives give you a positive 5. So that's how we get the 5 here. So that's the first thing we need to know, guys. Sometimes we just need to put numbers in the function. The second thing we need to know, guys, is composite functions, meaning f of g of x in this case. And the third thing we need to know is the inverse. Cool. So there are 3 things we pretty much need to know related to functions. Let me scroll down some more to see. So they ask us to find the inverse of the function, guys, f. And let me just write the function over here. F of x is equal to 3 minus 2x. So they ask us to find the inverse, guys. There are 3 steps when you find the inverse. Let y equal to f of x. So y is going to be equal to 3 minus 2x. Step 2 is make x the subject. So we're going to say y minus 3 is equal to minus 2x. I gotta end up with, no, I want that to be the opposite. I want to make x the subject there. So I'm going to say 2x is equal to 3 minus y, then divide both sides by 2. So I'm gonna end up with x is equal to 3 minus y over 2. Last part to find the inverse is change the y to an x and then set it equal to f to the negative 1 of x is equal to 3 minus x over 2. So that's the answer for this one. For the inverse, f to the negative 1 of x is equal to 3 minus x over 2. Cool. And the next one here, guys, says the composite function. So this was the second thing I was talking about to find f of g of x. We might need to find that. But here, guys, the composite function they ask us for is f squared. Sorry, is f squared of x. So what is f squared of x, guys? It's the same thing as f of x. So this means that you're gonna put f into f. So this here is f of x is 3 minus 2x. So we're going to put the same 3 minus 2x into the 3 minus 2x. 3 minus 2x. So we need to put this, guys, 3 minus 2x, and put it where the x is. So we're going to end up with f squared of x, or f of x, is going to end up being 3 minus 2 times 3 minus 2x. And that would give us the composite function f squared of x. So that would end up being 3, 2 times minus 3 is minus 6. Minus 2 times minus 2x could be plus 4x. And this is going to equal 4x. 6 minus 3 is minus 3. So f squared of x, guys, is equal to, sorry, let me put it over here. F squared of x, guys, which is f of x. So you put f in itself, is equal to 4x minus 3. Cool. That's the composite function. You put f into itself. Go ahead.
Sir, do back from the part where you get 2x.
2x. Where is that? Which
Sir,
part are you talking about?
From the part when it says f of x equal 3 minus 2 bracket 3 minus 2x. Oh, you get the 2x answer. And do what find that, sir?
Oh, well, the reason why, Adrian, is because for this down here, they're asking us for f squared of x. Guys, this is the same thing as f of x. So remember, f of x, guys, is equal to 3 minus 2x. So this is like putting it in itself. 3 minus 2x. So we need to put 3 minus 2x where the x is. So we're going to end up with 3 minus 2, and where the x is, put 3 minus 2x. That's what we did. And this will end up giving us 3 minus 6 plus 4x. So f squared of x is equal to 4x minus 3. By the way, guys, I have a whole video on composite functions on my channel. So if you want to look at it, I'm sure some people are probably looking at it tonight. See, I got a couple subscribers tonight. So I'm pretty sure people are looking at these tonight. before the exam. Not many people, but a couple people probably looking at it. But as I say, I'm not focused on the random people who I don't know. I focus on you guys. So cool. So yes, so that covers it, guys. That covers that. Covers that question. Cool. And this one now, guys, it says find the value of f negative 1 of minus 2. So this one kind of interesting still, guys, because f of f to the negative 1 is, this one is kind of different. Remember, f of x is equal to 3 minus 2x. And we just found the inverse, guys. The inverse, f to the negative 1 of x, is supposed to be, I think it's 3 minus x over 2. Yeah, that's it. So we need to put this now, 3 minus x over 2, into this. I think it's 3 minus x over 2. 3 minus x. Yeah, it's 3 minus x over 2. So we need to put that now in this one. So we're going to end up with f of f to the negative 1 of x is equal to 3 minus 2. Sorry, 3 minus 2 times 3 minus x over 2. That's what we're going to get. And yeah, this 2 will cancel that 2 to end up with 3 minus x. And this is going to be 3 minus 3 plus x. So that's going to be equal to x. So f to the f negative 1 of x is equal to x. And the answer here is just going to be negative 2 then. So f to the f negative 1 of x is just going to be equal to, well, of negative 2, sorry. It's just going to be equal to negative 2. So that's the answer for that one. I think that's the answer. Let me double check though, just make sure.
What's something miss?
Well, guys, remember that I have a video on this on my channel, just in case. Just in case. Cool. Oh man, I feel so tired, to be honest. How you guys feel? How you guys feel right now?
Kind of stressed, but yeah.
Yeah, but let me check with Trey. Trey, how are you feeling?
Feeling a bit tired now. Just want to wrap up a couple stuff and head to bed.
Yeah, I think that's a good idea. I don't think I should OD no more.
But
go ahead.
I was saying, if you're at composite functions now, right? So
yeah, I'm at composite functions now. So
I just need to go through linear programming. I don't know about the rest of them.
I think that's what we need to go through. I think that's what we need to go through too. Just in case it comes. Linear programming. That's about it. But everything else, guys, I can't do no more. I'm tired. And I think it gets stress you guys out actually. I don't think it make any sense to overdo it. Stressed, right? I can't do a marathon tonight. You know, I don't think that's sensible. And you guys need to get sleep now too. So what I think you guys should do is try to go to bed now. Try to ease down now and go to bed. We've been pushing it hard tonight, really hard. So let's see where I stopped. I stopped right here at functions and composite functions. What you could do before you go to bed maybe is just look at the videos I have on functions on my channel. Yeah, I think that might be good. For this, you can look at my exam tips, the short ones on my channel. These green videos, these very short videos, 2 minute, 3 minute, 3 minute, 3 minute. Watch these out, please. Watch those green videos, guys. Watch those green videos. Those green videos cover the measures of central tendency, probability. It covers that. Cool. Area, volume, surface area. I'm going to leave that to your common sense. So let me just talk about this section. Area, volume and surface area, guys, you want to use your formula sheet for that section. Cool. You definitely want to use your formula sheet. So let me go back up to the formula sheet.
This here is on the formula sheet.
Yeah, that section is always on the formula sheet. That section is always on the formula sheet, guys. So measurement, area, volume, and surface area, that's always on the formula sheet. See it here? Area of a sector, area of a trapezium, area of a circle, arc length, circumference, volume of a right pyramid, volume of a cylinder, volume of a prism, all of that is there on the formula sheet. So you really shouldn't get this question wrong. The measurement question, you shouldn't get it wrong because you can just look to the formula sheet and find the formula for the cylinder or whatever the case is or whatever it is. You should be able to find the formula for the shape in the formula sheet. So this is a breeze. I don't think I should go over that tonight either. This here investigation, guys, this is the pattern question, which you do 55 million times already. Yeah, we did that whole heap of times, guys. The pattern type question. Let me go down. It's like a number 7 that we've been doing. We did so many of them already. Yeah, these guys, these pattern ones. So let's look at this pattern. Let's figure out this pattern real quick. 1, 5, pi, pi, 2 pi. 2, 9, 4 pi, 3 pi, 6 pi. 3, 13, 9 pi, 5 pi, 12 pi. All right, so let's think about the pattern here. Just trying to show you guys, this is a pattern type question. There's a pattern somewhere. We need to figure it out. Let's figure out the pattern, guys. What's the pattern? 1, 5.
21.
2, 9.
Sir, you could have. Sir, you
3.
times 4 for each and every times 4. And I add 1.
Yeah, that's how it looked to me. Times 4, add 1. Times 4, add 1. Times 4, add 1. Yeah, times 4, add 1. 5 times 4, 20, plus 1, 21. Yeah, man. And then this now, let's look at this pattern for the pies. Let's look at the pattern. Let's figure out that one now. What's the pattern for that one? It's kind of interesting. So this one is 12, 6, 2, 6, 12, 20.
Would the one be 2 pi plus 1? Oh.
No, so that one they go by 4, 8, 12, and then it go by like 10 and maybe.
Yeah, this one. So 2 plus 4 gives me 6. 2 plus 8 gives me. No, it's not 8. It's 6. 2 plus 6 gives me 12, and 2 plus 8 gives me 20. So 2 plus 10 will give me 30 pi. So this one is 30 pi. Then this one is plus 2. This one is plus 3. Well, no. This one is just increasing by 2. Pi plus 2. 3 plus 2 plus 2, 9 pi. Cool. So this one kind of easy still, not too bad. So this would be n times 4 plus 1. Cool. This one would be n times, no, not times.
Sir,
n plus 2
minus 1.
Hold on, let me check. Let me think about this one now. And n plus 2. Yeah, I think it's n plus 2, is it? No. I need a pattern. This is n times 4 plus 1 though. I need some patterns for this one, man. I need to figure this out. But these are the type of questions you can get for that section though, for sure. Oh, cool. So this one is squared. I didn't realize that one. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So this is n squared. N squared times pi, for sure. This one is 2n minus 1 times pi. 2n minus 1, 1. Yeah, 2n minus 1 times pi. And the last one is n squared plus n times pi. Yeah, this one wasn't too easy still. Not too easy. But try to figure out the pattern for this type of question, guys. Look at the pattern. Try to figure out the pattern. So that's it, guys. That's it for that type of question. Figure out the pattern. I hope they give you something easier though than this pattern. I don't think that pattern was so easy. I hope they give you an easy pattern tomorrow. And then these now, the matrices, vectors and matrices, guys. I'm sorry, I just don't have enough time to go over it. But for vectors and matrices, guys, you need to know how to find the inverse. You need to know how to add, subtract, multiply, and divide. So, guys, I have a section on this. Where is it? Section 8, matrices. So if you want to go through it really quickly, we can go through it quickly still. So, guys, in order to find the inverse, let me just show you really quickly. So first of all, to find the inverse of any matrix, you need to find 1 over the determinant multiplied by A adjoint. Cool. So how do you define the determinant, guys? You cross multiply. So the determinant of A is equal to, this case, 1 times 4 minus 3 times 2. 4 minus 6, it will be negative 2 in this case. And A adjoint, guys, you switch the main diagonal, A adjoint, switch the main diagonal, 4, 1, and then you put a negative on these two, negative 2, negative 3. So the inverse for A, guys, would be 1 over minus 2. The determinant is minus 2. Times A adjoint, which is 4 minus 3, minus 2, 1. And you would end up with 4 over 2. Well, 4 over negative 2, negative 4 over 2. 3 over 2. This would end up being positive. 2 over 2 and negative 1 over 2. So this is the inverse. So A, negative 1 here is 2. 4 over 2 is 2. Negative 2, sorry. 1. 3 over 2, negative a half. That's the inverse for this matrix. Oops, sorry. Yeah, that's the inverse for that matrix. So you need to know how to find the inverse, guys. How do you find the inverse? 1 over the determinant times the adjoint matrix. Go ahead.
Sir, we can give you one so you do it, come and understand.
No, bro. No, I'm sorry, Adrian. We just don't have enough time, you know. And you need to go to bed. Like, I can't keep you guys up forever, you know. So how to find the inverse? See it here. There's a video on it, guys. You need to look in my channel. Look on my YouTube channel and watch it. If you don't remember how to find the inverse, watch this video on how to find the inverse. I can't show you now. It's too late, and I don't want you to. I don't want to keep you guys up in the night. You guys can stay up in the night, you know, if it's up to you. But I can't keep you guys past 9. That would be irresponsible because some of you guys may get tired for the exam tomorrow, and that would be my fault. So I can't keep you past 9, actually. But as I would say, use the videos here. For these 4 videos are enough in terms of how to find the inverse. And look up a multiplying matrices video as well. Cool. Position vectors, guys, and the triangular parallelogram law. We kind of did these already still, so yeah. Maybe I should send a video into the group on vectors. Vectors. Where's my bridging? Vectors and matrices. Hey, see a little mini marathon here, guys. You can watch this if you want. Kerwin have a little marathon 4 days ago with it. You can look it up if you want to, guys. Vectors and matrices. Might send this into the group though. And the quality is poor though. So yeah, you can probably look up one if you want still. It's really up to you guys. But one last thing before we go, guys, there's something that I sent into the group recently, July 2020, paper 1. I sent that into the group. So guys, tomorrow you have 2 exams, am I right? One in the morning and one in the evening, don't it? See it here?
Yes, sir.
So mathematics, what date is it? Where is the date? Where is the date? Tomorrow. But I don't know. These are the topics though. I want the timetable.
It wouldn't be on the syllabus.
It's not on the syllabus thing. All right, cool. So, all right. So what time is it? What time is the exam tomorrow? Let's be specific, guys.
9.
9 a.m., right?
Yeah, 9
So
a.m.
9 a.m. So you need to get 8 hours rest, right? 9 and 1. Which one is first? Which exam is first?
Paper 2.
Paper 2, right? Paper 2 is first. Paper 2 is first. Yeah, 9 and 1. Paper 2, 2 hours and 40 minutes. So by 12 o'clock, you done that paper. So guys, between the 9, between when you finish the paper and the 1, try to look through these multiple choice quick. If you can still, it's up to you guys. But try to look through these multiple choice that I just sent into the group last night. 2020 paper, this one, I sent these videos into the group. Let me send them again. Try to look at these if you can. In that 1 hour lunchtime you get, try to just look at these. Got them going to repeat. Cool. And if you don't feel like rushing, don't rush. You know, don't rush. But if you can look through, just look through it slowly. You know, just say, all right, number 1 is that. All right, number 3. All right, cool. Take your time and look through it slowly. Right before the paper. Right before the paper too. Why? Because you never know. It can, a lot of them can just repeat. And that's what you want. You just want them to repeat, you know. But did anybody go through these last night? Did anybody go through these today?
No, I had English on my mind.
All right, so you had English. But did anybody go through these yesterday, at least?
Also, I went over the 2019 today.
Well, if you went over the 2019, fine. That's good enough. But yes, if you went over the 2019 one we did today, fine. That's good. But if you can find the time to go over this one, these 2 I just sent into the group as well. I just sent them into the group. Because this is the latest paper, guys. This is last year's paper. If you can find the time to go through these, Mark, enough of them are repeat same way. Just take a peek at them, you know. I'd probably watch this before bed, actually. Because, yeah, I'd probably watch that before bed, maybe. Well, it's up to you guys still. I'm not really sure. But the exam is 9. So it's up to you still. It's up to you. I don't really feel like we'll have that much time. The exam is tomorrow, guys. So guys, get some good rest still. I think it may be good. Let me try to find a linear programming question though. Programming, CXC. Linear programming. It did say linear programming still. Man, it's too late, isn't it? I'm gonna send this video on linear programming still. Almost done, guys. But the only thing I probably did not cover on the whole thing here is linear programming. I didn't expect it to come. And I wasn't really thinking about it, to be honest. But I think it might come for you still. So yeah, it might help to look through this. It might help to look through this tonight. So it's a 9-minute video for linear programming, guys. I'm gonna send this into the group as well. Yeah, I'm gonna send this into the group. Let me stop sharing for a second. Okay. Give me a second, guys. Just want to send it and then. Yeah, so let me send the linear programming into the group too. Yeah, let me send those into the group. So if you need help with linear programming, guys, it seems that a linear programming question is gonna come anyway. I really did not expect that to come on the exam at all. I mean, I saw it there, but when I really think about it, what would they put on that? Linear programming. Relations, functions, and graphs, linear programming. So guys, yeah, it might make sense to go through this just before we leave, you know. What time is it, guys? Let me check. Share screen. Yeah, guys, we need to go to bed though, for real. Number of orchids must be. All right, guys, so just watch this video. That's all I'm going to ask you to do. Before you go to bed, watch this video, the linear programming one, please. That's it. I can't do no more. I think that's good. I think I'm good. I did everything I could. But related to linear programming, just watch this video. Just watch this video. It's 9 minutes, 10 minutes long. Watch that before you go to bed and boom, do your best tomorrow. I think that's the best we can do here. Am I right, guys? How you feeling? You feeling okay?
Yes, sir.
You should be tired by now. Take a break now. Relax, eat your dinner or something. And then before you go to bed, watch the linear programming video. And that's it. Cool. Then do your best tomorrow. Do your best and let God do the rest. And I'm quite relaxed. I genuinely feel like a lot of you guys get it well still. I expect you guys to get ones, to be honest. I'm kind of really confident. I'm really confident in a lot of you guys. So just do your best. Do your best. Don't worry about the exam. Just do your best. That's all you can do. You know, you can't do more than your best. So just do your best, guys. I'll be proud of you no matter what your grade you get. I don't think any of you guys are gonna fail. That much I can say. For the adults who have paper 3 Friday, I think I'm gonna see you guys Thursday night for sure. Paper 3 candidates, I'm gonna see you guys Wednesday and Thursday night. Cool. We need to talk. We'll have one paper on the 9th, which is my birthday. My birthday is Friday coming, guys. So yes, the adults, I have you guys left, but everybody else should be done tomorrow. So good luck, guys. We're going to say a prayer. Let's say a prayer before we go. Yes, let's say a prayer. Yes, cool. So we're gonna play some gospel and say a prayer. Yes, we're gonna say a prayer before we go. Yes, guys, we're gonna play some gospel. Play some gospel. All right, guys. So, guys, we're going to say a prayer. Lord Jesus, please, I'm asking you to give all my students the strength to just do well tomorrow. Help them to do their best. Help them to stay positive, no matter what the situation might be for them. Please give them the strength, Lord, to just do their best. Their best is enough, definitely more than enough. Help them to be calm tomorrow. Help them to take deep breaths before the exam. Help them to remember that you are in control. and help them to just stay focused tomorrow. Also, Lord, I'm asking you to please remind the students to do the easiest questions first, because that's how you do this subject. And God, please guide them through to get ones for the exam. In your name we pray, amen. Just help them to do their best, God, please. And that would be enough for me. So guys, let it rain, guys, let it rain. Send down the blessing, God, send down the blessings when the blessings have to flow and the prayer go up, right? We've been really working hard, guys. We've been doing so much work in the last couple of weeks. Like, we had class today, we had class yesterday, we had class Sunday. We've done a lot, guys. We've done a lot. We've done much more than normal, than the normal person. You guys are, I think you guys are more prepared than the normal person tomorrow. So just do your best, guys, and get some rest. Get some rest. And I'll see you guys tomorrow. I'll talk to you guys after the exam. Cool. Also, guys, don't let one exam get you down for the other. Once you do the first paper too, move on, start to think about the next paper. Cool. Stay safe and God bless, guys. Do your best. Cool.
Thank you, sir.
Good night, guys. I'll see you guys tomorrow evening, hopefully. I'll talk to you guys tomorrow, man. Cool.
Yeah, no problem.
All right, take
Night,
care.
guys.
All right, sir. Thank you. Thank you very much.
You're welcome, Deshaun. You're welcome. You're welcome, all of you. I really did the best I could. And all the best. All the best, guys.